countdown.
Congratulations! This live broadcast is specially brought to you by Academy YouTuber Malaysia, an initiative by Didik Malaysia and Kelab Guru Malaysia. Please pay attention. The live broadcast will begin shortly. The link to the certificate of attendance will be provided at the end of the session. Please make sure it is filled within the stipulated time. Thank you.
Bismillahirrahmanirrahim. Assalamualaikum. Good evening and hi to all teachers, parents and the wonderful students. Welcome to Pusat Tuisyen Academy YouTuber, a joint venture with Didik Malaysia and Kelab Guru with the hashtag bermula percuma, selamanya percuma. Okay, before we proceed, let's begin our session with the recitation of Umul Kitab Al-Fatihah. And for the non-Muslim, please take a moment of silence. Okay, how is everyone doing today? My prayer is that everyone is in the best of health and ready to proceed with today's class. And let me introduce myself first. Okay, I am Madam Rosmaya from SMJK Yuhua, Kajang, Selangor. And today we have another teacher with us, Nun, Cikgu Nun, okay, Madam Nun from College Matrikulasi Negeri Sembilan. Yeah. Okay, so before we start our discussion today, please subscribe to my channel and also Teachers Known channel, okay, so that you won't miss any of our new video in the future. As usual, the lesson will last approximately for 1 hour, and the certificate link and the credit claim link will be given at the end of this session. You can also use Didik email and more email to claim the certificate. Okay, so I will put the link to apply the Didik email in the chat box now. Okay. Okay, so be sure to follow the class up until the end and give your full cooperation in making this lesson a lively one. And I would also like to remind students to use appropriate language and also use appropriate profile picture, if possible your own picture, if you wish to post comments in the chat box. So I'm pretty sure all of the students here are excellent students who will uphold a positive classroom environment. Okay, so I can see there, Chia Yao. Okay, your what note there? Okay, hi Chia Yao. Okay, stay focused, everyone. And if you have any question, please write in the chat box. So, without further ado, okay, I will announce the first letter, and together with 2-digit codes for credit claim. Okay, so the code is A 27. Okay, the number is 27. The letter A. Okay, so now I'm going to open my slide. Okay. Okay, my slide. There you are. So let me introduce the pre-U teams that we have in Academy YouTuber. Okay, so physics team lead by me, and we have teacher Non with us, and another 2 teachers in this physics pre-U team is teacher Su and teacher Hafsah Hayu. Okay, so in mathematics team lead by teacher Im. Okay, biology pre-U lead by Cikgu Faiza. Chemistry pre-U Cikgu Shahnon, and the leader for perakaunan and economy pre-U lead by Madam Fizi. Okay, so now I'm going. Okay, Academy YouTuber also has the apps where you can download from Google Play Store. So there are a lot of videos there, including the physics video. Okay. Okay. So now we have come to the main objective for today. Okay. So today's live tuition class, we are going to do some revision on topics electricity, chapter 12 to 15, part 2. The first part we've done last week. So today continue part 2. A few more questions we discussed today. So I will have posted the link to the PDF question in the description part below this video, and also in the chat box, the PDF link for the PDF question. Okay. So now we go to question number 1. Okay. So let us read the question first. Okay, so two small balls with a mass of 0.5 gram are hanging on two separate strings, 1 meter long, attached to a common point. So they are given an identical charge. Okay, they are given an identical charge and spread apart to a distance 4 centimeter from each other. So determine the charge of the balls. Okay. Okay. So how to imagine this? So this is two small balls. Okay. So they are given charge. So that means their charge is the same. If they are positive or they are negative, both of them have same charge. They are like charge, like charges. So they repel each other. So therefore, there are three forces act on the ball here. Okay, we have weight, okay, mg. We also have tension in the string, and one more is electrostatic force. The direction is to the right, okay, to the right, okay, because they repel each other. Okay, so there are three forces act on the balls here. Okay, so the component of T we can resolve into two components, okay, horizontal and vertical. Okay, with angle theta we can find later using trigonometric ratio. Okay, so the component is T cos theta and T sin theta. Okay, so because this ball is in equilibrium, okay, so the T cos theta is equals to the electrostatic force. Because the ball equilibrium, and the upward force is T sin theta equals to mg. So from these two, we can use ratio, and the electrostatic force we can use Q squared per 4 pi epsilon naught R squared, because they have same charge. So Q squared per 4 pi epsilon naught R squared. Okay, so now we use ratio equation 2 divided by equation 1. So sin theta per cos theta becomes tangent theta. Okay, and T we cancel out. Right side become mg per q squared per 4 pi epsilon naught R squared. Okay, so we rearrange this equation. Okay, we get this. Okay, now for the theta, okay, we can use trigonometric ratio. Okay, and the side here is 1 meter, and below here mention 4 centimeter, right? They are separate by 4 centimeter, so that means half of the length here becomes 2 centimeter. Okay, so we can use Pythagoras theorem for tangent theta. So we need to use trigonometric ratio. Tangent theta equals to opposite per adjacent. So we use Pythagoras theorem to find this side, this side. Okay, so we get 1 meter also. Because this is too small, actually it's 2 centimeter compared to 1 meter, very small. So when we round this off to to a whole number, we still get 1 meter. Okay, so it's logic lah, 1 meter here, 1 meter here also. Okay, so now we can use trigonometric ratio. Opposite is 1 per adjacent. Adjacent is 2 centimeter, convert to meter. So this is tangent theta. And we can solve for the charge. M 0.5 gram, okay, convert to kilogram. G value is 9.81. 4 pi epsilon naught r squared is 1 per 899 times 10 to the power of 9. Okay, so calculated this already. And the Q squared. Then we get Q equals to 4.2 times 10 to the power of negative 9 coulomb. Okay, so those who get the answer, same as me, can write there in the chat box. Okay, so now let's go to the next question. If you've got any question, you can write there in the chat box. Okay, now next question. Question 2. Okay, how many 1 microfarad capacitors must be connected in parallel to store a charge of 1.00 coulomb with a potential of 110 volt across the capacitors? Okay, so we have one capacitors with 1 microfarad. So we are going to connect it in parallel. Okay, how many we don't know yet. We are going to find how many connect in parallel. And for parallel capacitors arranged in parallel, okay, the effective capacitance is C1 plus C2 plus ... We don't know yet how many. So we add them. Okay, the capacitance. So capacitance 1 microfarad for 1 capacitor. Okay, so how to solve this? We are going to give a potential, okay, 110 volt across it. So we can use Q equals to CV to find the charge. The charge. The charge. So C effective Q per V. So for C effective, charge is 1 coulomb. Okay. So 1 per 110 volt across all these capacitors. We don't know yet how many. So the effective capacitance will be 9.091 times 10 to the power of negative 3 farad. Okay, so this is the C effective for this volt, for this voltage, 110 volt. Okay, so now for 1 microfarad is for 1 capacitor. So if this many farad, okay, capacitance, so how many capacitor? Because this is in addition form. Okay, so we can use ratio to find how many capacitors are there. Okay, so for this one we can use ratio. Okay, we use 1 per 9.091. Okay, don't forget the here micro, right? And below is the 9.091 times 10 to the power of negative 3 farad. Okay, equals to, right side is 1 per x. This x is the number of capacitors and we are going to find, okay, how many capacitors, and we cross multiply and we get the need here need 9,091 capacitors. Okay, the number of capacitors needed is 9,091 capacitors. So that's the answer. Okay, so we go to the next question. Okay. So next question 3, continue. So you just stay focused there, okay, Chia Yao, okay. No need to you are every lesson you are here with me. Okay, thank you, Chia Yao. Okay. I pray that you will become the best physics students. So physics lovers. Okay, Chia Yao, you are physics lovers. Okay, so now we continue with the question 3. Okay. Okay, question 3. A parallel plate capacitor with separation of plates D, which is fully charged by a battery to charge I read again. A parallel plate capacitor with separation of plates D, okay, given as D, which is fully charged by a battery to charge Q naught, okay, shown in the diagram below. So the battery is then disconnected from the capacitor, and the distance between the plates X is increased slowly. Okay, so which graph shows the variation of the charge Q with X? Okay, so there are A, B, C, D. Answer. Which one shows the graph Q against X? So anyone got the answer? It's very simple actually if you understand the concept. So in this story, okay, the question said that we take out the battery, okay? Battery is then disconnected, so we take out the battery. So after it is full charge, after it's full charge. So the charge remain here, remain in the capacitor, cannot go anywhere, okay? Then we slowly, okay, increase the distance, okay? Increase the distance of the plates here. Okay, so what happened? So from Q equals to CV, okay, and the C equals to epsilon naught A per D. Okay, the D here, when we separate the distance, increase the distance, so that's mean the capacitance will become less, reduce, okay? Capacitance reduce. So if the capacitance reduce, so there are also changes in the voltage, voltage, but the Q remain the same, the charge remain the same because it cannot go anywhere, cannot go anywhere. It still remain there in the plates, in the two plates, in the capacitance, in the capacitor. So therefore, the best answer will be A. Okay, so the graph here shows the horizontal line. That's mean the Q remain the same. The changes is between the voltage, between the plates, because of the changes in the D. Because also the capacitance change. How they change? Okay, this is how they change. Okay, so now next we go to question 4. Okay, question 4. Okay, let's read the question together. Okay, question 4. A proton enters a uniform electric field at X, okay, at X here, from here, and moves in a parabolic path to Y, okay, towards Y here, to Y as shown in the diagram below. So this is a parabolic curve, parabolic path. So if the electric field strength is 500 volts per meter, okay, what is the change in kinetic energy of the proton? Okay, change in kinetic energy. So this is the path taken. Okay, parabolic path. Okay, change in kinetic energy means that the final energy, kinetic energy minus the initial. So this means it's a work done. Okay, work done. So change in kinetic energy is work done. So because if we use formula half mv squared, we don't know the speed. So therefore, we use the formula force time distance instead. Force time distance. Okay, so work done is F dot S. So that means we choose the force that parallel to S. Okay, force in the direction of S. Okay, force in the direction of X will be this way. Okay, because the curve move this way. Okay, the curve moves this way. So that means the force is to the right. Look at the electric field here. Okay, electric field is this way. So that means negative plate somewhere here, negative plate. This is positive plate, negative plate, and the proton is positive charge attracted to the negative plate. You can imagine like that. So therefore, the force is this way. Okay, and from the given path also we can know the force is this way. So the force times distance, we use distance along the force here, which is 0.40 meter. So the force is QE times the distance as 0.4. So substitute the values of charge. Okay, 1.6 times 10 to the power of negative 19 times the electric field 500 volt per meter. E is electric field and the distance 0.40. You cannot choose 0.30 because this distance is perpendicular to the force. For work done, F dot S, F and S must parallel to each other. So therefore, the answer is positive 3.2 times 10 to the power of negative 17 joule. Okay, so answer number 4 is D. Okay. Okay, Chia Yao, where you gone wrong, you know already. Okay, so the answer is D. Okay, good try, good try. Okay, now we go to the question 5. Okay, question 5. We read the question. A parallel plate air-filled capacitor shown in the figure has a capacitance of 2 microfarad. Okay, so this one. Okay, 2 microfarad. And then it is half filled with with a dielectric, okay, of dielectric constant 3. This one. From here, we insert the dielectric, but halfway only, halfway. Not halfway, half of the distance, okay? So the capacitor becomes how many? A, B, C, D. We don't know that which one. So how to calculate? Because of it is inserted half of the distance for in the plate. So therefore the D becomes D per 2. Another one for air is D per 2. The distance become half D. Okay, this is with dielectric and the top one is with air. So the equivalent circuit. Okay, so the equivalent circuit is like this. Okay, it is as if the capacitance is arranged in series. Okay, it's arranged in series. So C1 represent the air capacitance with air filled. C2 represent the capacitor filled with dielectric. Okay, this is the equivalent capacitance. So we can use formula for the series capacitors arranged in series. So the formula of capacitance is epsilon R epsilon naught A per D because we have dielectric here. Without dielectric, just epsilon naught A per D. Okay, so we calculate this first. The capacitor with air, we use epsilon naught A per D. And for the air here is epsilon naught A per half D. Okay, because epsilon naught only because it's air. And we can substitute the C here into the equation C1. So we get actually the capacitance is 2C of the initial, this one. For the C1, for the C1 is 2C. And we do the same for, this is C1, 2C. Okay, so we do the same for the dielectric. For C2, it's we use epsilon naught R, epsilon naught A per D. So the D is half D. And epsilon R is 3 given here, the dielectric constant K. Okay, so we bring 2 up, we get 6 epsilon naught A per D, and epsilon naught A per D is C. Okay, so C2 in terms of C is 6C. Okay, 6C. Okay, so therefore we have two values of C1 in terms of C. C1 is 2C and C2 is 6C. Okay, so now we use formula for capacitance arranged in series. Okay, so it's opposite of the resistor. Okay, opposite of the resistor. If resistor arranged in series will be total the resistance, total up the resistance. But for capacitor, if arranged in series, we use 1 per C. 1 per C equals to 1 per C1 plus 1 per C2. Okay, this formula. Okay, so choose this one and we get, we substitute 1 per 2C plus 6C here. Okay, so we get, and also C is given 2 microfarad. Okay, substitute 2 microfarad into here. No need to convert to farad because all the answers given here also in microfarad. Microfarad. So no need to convert the unit. And we get the answer 3 microfarad. Okay, so the answer is C. C. Okay, Chia Yao, C. 5C. Okay, so next we go to question 6. Okay, question 6. Okay, using Kirchhoff law, Kirchhoff rules, determine the value of unknown resistance R in the circuit. Okay, so that no current flows through 4 ohm resistance. Okay, no current flows to 4 ohm resistance. So what R is needed to be put here? And then find the potential difference between points A and D. Okay, so we've discussed the Kirchhoff rules last week. So today there are 2 rules of Kirchhoff rules. So today we are going to use the Kirchhoff rules again in this question. So first determine the direction of current. Okay, it's up to you which way you want to choose. So usually the charge, the current flow from high voltage to low voltage. But actually it doesn't matter the direction of current you choose, because at final answer you will get I in negative form if you select a wrong direction. So it doesn't matter actually. Okay, so let's say we choose this I into this in this direction. Okay, then we name this I1, this is I2, this is another circuit, this is another circuit one way, this is another one direction. Okay, and this is another direction, I3. Okay, so using and I3 is 0 mentioned in the question. Okay, so using the first rule for Kirchhoff rules, so choose the junction here. So I entering the point I1, and out of the junction here will be I2 and I3. So I2 plus I3. I in equals to I out. Okay, I in only one, and then there are 2 I out. I2 and I3. So 2 I's here. Okay, so I3 we know that is 0, the question mentioned. So that means I1 must be equals to I2. Okay, I1 must be equals to I2. Okay, so now this is equation 1. Next we use second rule. For second rule, you choose a path in any direction. It's up to you. Let's say I choose here in a clockwise direction. Okay, so for clockwise direction, there are 3 resistors. Okay, so that's mean the product of IR, okay, will be one I1, okay, and this also one I1. And for the I3 is 0, 0. So no need to write, also can. Okay, so there are 3 resistors here. So the product of IR, 3 here, but this one is 0. Okay, so no need to put also, is okay. Okay, now the next one is the product of EMF. So we have 9 minus 1 EMF. We have 9 volt and 6 volt here. So determine the direction of electric field. So from terminal positive here, okay, in this direction. Okay, look at this, both of the 9 volt and 6 volt direction of the electric field. Okay, now check the 9 is positive because same direction as the loop. Same direction as the loop, positive. And for the 6 volt, the direction is opposite. So that means you minus, okay, 9 minus 6. Okay, now we solve for I1. I1 is 3 per 2. And this I1, 3 per 2 is also equals to I2. So they are equals in magnitude. So both I1 and I2 is equals to 3 per 2. Okay, the second loop, we choose also clockwise. It's up to you to choose clockwise or anti-clockwise, but I choose here clockwise. So in this loop, the path taken here, there are 2 resistors. So that means the product of IR will be I2R. The current pass through R is I2. So the product of IR is I2R plus 0. Another one, 4 ohm, I3 is 0. So I2R plus 0. And the product of EMF on the right side will be 6 minus 3. So why 6 minus 3? 6, the direction of electric field is this way. Okay. So it's same, okay, for 6 volt first. So same direction. So 6 is positive. and 3 volt will be negative because opposite direction. Okay, so opposite direction negative, same direction 6, positive. 6 is same direction, and we solve but for R by substituting I2 into here, and we get R equals to 2. Okay, so that no current flows through 4 ohm. So this is the answer. Okay, R equals to 2. And for potential between A and D, okay, you just choose one path. Many paths can be chosen here. You can use A, B, E, D path or A, B, C, D path. But I just choose for discussion today, I choose A, F, E, D. Okay, A, F, E, D. Okay, this path. So the potential difference, the product of IR along this path is, we have two resistors, resistance here, two resistors with resistance, okay, 1 ohm, 1 ohm. So the total will be 1 I1 plus 1 I1, same I1, right? And then we substitute the I1 and we get product of IR is 3 volt along here. And then the product of and the total of EMF along the path. Okay, along the path here there is no EMF. Okay, no EMF. So therefore the EMF is 0. Okay, EMF is 0. And the potential difference, okay, so the difference will be 3 minus 0, so we get 3 volt. Okay, the answer is 3 volts. If you choose path A, B, E, D, you will get same answer also, 3 volt. And even if you choose the path A, B, C, D, also you get same answer. Potential difference between A, D is 3 volts. Okay, you can try that on your own. So I just show you for A, F, E, D only. Okay, the path A, F, E, D. Okay, hopefully you understand how to get the potential difference. And I think we already for 30 minutes, so we can go for iklan, break time, okay, advertisement. So where is, okay, before we take a break. Okay, before we take a break, I would like to announce the third digit code first. The third digit code. Okay, so before we take a break, okay, the third digit code is number 6. Okay, number 6. Okay, teacher Non, number 6. Okay, so iklan ready.
Berita baik untuk semua. Kini Akademi YouTuber memperkenalkan sistem mata gancaran kredit AYU untuk dikumpul. Jom ikuti kelas tuition live AYU untuk mengumpul kredit AYU dan berpeluang menebus hadiah-hadiah yang menarik. Hadiah bernilai lebih RM10,000 disediakan secara percuma untuk pelajar seluruh Malaysia. Apa tunggu lagi? Tebus ganjaran hebat ini sekarang. Layari www.academyyoutuber.com untuk maklumat lanjut.
Okay, welcome back. Okay, so before we continue, I think I'm going to announce the fourth digit code. Okay, so the fourth digit code for credit claim is number 9. Okay, number 9. Okay. Okay, so we go to the question 7. Continue discussion on question 7. Okay, we read the question together. In an experiment for calibration of voltmeter, a standard cell of EMF 1.5 volt is balanced at 300 centimeter length of potentiometer wire. The potential difference across a resistance in the circuit is balanced at 1.25 meter. So if voltmeter is connected across the same resistance, it reads 0.65 volt. So the error in the voltmeter is, okay, so what is the error in the voltmeter? Okay, we know that the potentiometer wire, the potentiometer is used to measure potential difference. Okay, so potentiometer is used to measure the potential difference accurately. Okay, more accurate compared to voltmeter. Okay, so that's why there is an error in the voltmeter. Okay, now we can, there are three mentioned here, three circuits mentioned here. So for the standard cell of EMF 1.5 volt, balance at 300 centimeter length of potentiometer. Sorry, this one, the EMF here 1.5 volt connected to the potentiometer. This is potentiometer. So G set to 0. So it's given here is 300 centimeter length. Okay, the balance length. Okay, another. So we use the potential divider formula. Okay, so from this potentiometer, arrangement of the potentiometer. So 1.5 volt here equals to 300 per length of the wire. This is length of the potentiometer wire here times the source here, EMF, this EMF. So this is equation 1. Okay, next for this one, the potential difference across a resistance in the circuit is balanced at 1.25 meter. Okay, so this is another connection of potentiometer. So if we connect a resistance to this circuit 1.5 volt just now, so the balance length becomes 1.25 meter. Okay, 1.25 meter. So in centimeter is 125 centimeter lah. Okay, so now we use potential divider formula. So the EMF 1 here is equals to the 125 per the length of the potentiometer wire times the EMF here. Okay, EMF here is equals to the EMF across the wire here, potentiometer wire. Okay, so right side is this EMF. Okay, so now we do the same for the third information from the question. Voltmeter is connected across the same resistance. Okay, here the same resistance. So it reads 0.65 volts. Okay, it reads 0.65 volt, like this one. If we choose voltmeter instead of potentiometer, these two we use potentiometer. This one we use voltmeter. The answer given 0.65 volt. Okay, so now we are going to find this EMF, EMF 1 using potentiometer. Okay, when the circuit is complete by adding the resistance to this circuit. Okay, so now we can use ratio to find EMF 1. Okay, EMF 1, this EMF, when this is a complete circuit. Okay, so we use ratio E1 per 1.5. Right side will be this one per this one. Okay, cancel the EMF from the potentiometer circuit here. Okay, so we get EMF equals to 0.625 volt. Okay, use ratio method. So we get EMF 1 here is 0.625 volt, which is actually more accurate, compared to the using voltmeter. And you can see the error here is how many? So you minus 0.625 0.65 minus 0.625. So the error is 0.025 volt. Okay. Okay, so that's the answer. Okay, next question 8. Okay, question 8. You are given a bridge circuit. Here, bridge circuit. Equivalent resistance between A and B will be, okay, so we are going to find equivalent resistance between A and B. Okay, so if you are given this kind of circuit, you must always check and using Wheatstone bridge formula. Can you remember or not Wheatstone bridge formula? This is a Wheatstone bridge formula. Okay, so P per Q equals to R per S. P is the resistance. PQRS is resistance. So the ratio, we check the ratio first. If they are the same, so that's mean there is no current flow through 7 ohm. In this case, 7 ohm lah. Okay? Or in this Wheatstone bridge equation, so the G shows 0 reading. Okay, this means no current flow through galvanometer here. Okay, when the ratio of the capacitor, resistor here is the same, resistance. Okay, now we check. We have 3 per 6, and check another one, 4 per 8. They are same in ratio. Okay, 3 per 6 equals to 4 per 8. So what does this mean? This means no current flow through 7 ohm. So that's mean this circuit is as if there is no resistor there. Okay, because no current flow here, so we can ignore the 7 ohm resistance. Okay, because they have same ratio. Okay, or you can use 3 per 4 equals to 6 per 8 also can, because when you cross multiply, you still get the same answer. Okay, the same answer. So it doesn't matter. 3 per 6 equals to 4 per 8, or 3 per 4 equals to 6 per 8. Okay, so same ratio, that's mean no current flow to 7 ohm. So you can ignore the 7 ohm to find the equivalent resistance. So in this case, that's mean potential at this point is equals to the potential at this point, because no current flow. Remember that current flow when there is difference, when there is potential difference. In this case, potential is the same. So no current flow from this point to this point. Okay, so now use the formula for the resistors arranged in series and also a resistance arranged in parallel. Okay, use these two formulas to find the effective resistance or equivalent resistance. Okay, so for the 3 and 4 they are arranged in series, so that's mean 3 plus 4. Okay, this equation. 6 and 8, they are arranged in series, so that means 6 plus 8. And then these two set of resistors, they are arranged in parallel, so you use this 1 per set of 3 and 4 plus 1 per 6 plus 8. And you solve, you get R effective 14 per 3. Okay, so that's the answer. The answer is D. Okay, very simple actually. The secondary school concept with the form 6 STPM level. Okay, and what about matriculation? They learn this or not? They also learn this or not? Got this, the syllabus is in the syllabus in matriculation syllabus or not? No. Okay. So now we go to question 9. Question 9. Okay, question 9. Let's read the question. So two cylindrical resistors R1 and R2 are made of the same material. Okay, same material. What does this mean? Same material. That means their resistivity is the same. Okay, automatically in your mind. Okay, in your mind, if same materials means same resistivity. Okay, R2 has twice the length of R1. Okay, twice the length. Okay, I2 2 here, resistor 2, but half the radius. You can see from the diagram, half the radius of R1. Okay, these resistors are then connected to a battery V as shown. So what is the relationship between the resistance of R1 and resistance of R2? So what is meant by this question, relationships? That means you must write R1 in terms of R2 or vice versa. Okay, R1 in terms of R2. So let's do how to find the relationship between R1 and R2. Okay, we do question 1 first. Okay, same materials mean resistivity is the same. Okay, let's say we use rho, the symbol here. for resistivity. And the formula for R1 is rho L per A, repla. Okay, how to memorize this equation? You can use repla. Okay, and then for R2 is rho L2 per A2. Okay, different length, different cross-sectional area. A is cross-sectional area, okay, of the resistor. Okay, so now we substitute L2 given here. L2 is twice length of R1, so means 2L1. Okay, and then A2 is, we need to find A2 first because given here diameter, right? Diameter, half diameter. So we use pi r squared. We assume the cross-sectional area is a area of a circle. So formula is pi r squared. So A1 is pi R1 squared. Okay, R1 given, this one R1 given. So that's mean pi. For A2, the R1 is half, become half. Okay, radius, half the radius here. So half of R1. And you can use ratio to find A1 in terms of A2. Cross multiply, cancel pi, cancel R1 squared. You get A2 is A1 per 4. Then you substitute into here. Okay, then you can then you can simplify and you get R2 is 8 resistivity rho L1 per A1. Okay, so what is rho L1 per A1? It is R1. So you can substitute this into here, you get 8 R1. So that's the answer. Okay, what is the relationship between resistant R1 and R2? Okay, their relationship is R1 is equals to the 8 R1. Okay, very simple. Okay, you can use, actually this one, all this is simultaneous equation. Use the simultaneous equation. It's up to you to use ratio method or substitution method, is up to you. Okay, so the answer is R2 equals to 8R1. Okay, so we put it here and continue with question 2. Okay, question 2. What is the relationship between I1 and I2? I1 and I2. Okay. Okay. So the resistors have the same voltage because they are arranged in parallel. So that means they have same voltage. So we are going to use this physics concept. Same voltage. So for V equals to I1 R1, another one is V equals to I2 R2. So their V's same, they are the same. So I1 R1 equals to I2 R2. So you just substitute the R1 and R2 you found just now in question 1. Okay, or you can use this method, equate them and substitute R2 equals to 8 R1 and cancel the R1 and you get the relationship between I1 and I2. So I1 is equals to 8 I2. Okay, very simple actually. You just need to understand the electricity concept. Arrangement of the conductor here, resistor here, arranged in series or in parallel. Okay, so that's the answer for question 2. Next, we go to question 10. Okay, question 10. A nickel coil has a resistance of 13 ohm at 15 degrees Celsius. If the temperature coefficient of resistance at 0 degrees Celsius is 0.006 per degree Celsius, okay, so the resistance at 0 degrees Celsius is, okay, can you all remember what formula to be used here? Okay, many students I found forgot about this, the formula of this one. Okay, so what is the formula we are going to use? So memorize this formula. Okay, for temperature coefficient, alpha. Alpha is temperature coefficient. So R equals to R naught bracket 1 plus alpha change in temperature. Okay, forgot to put the close bracket here. Okay, so what is alpha? Alpha is 0.06 per degree Celsius. And then this is the T naught. T naught means this one is for the increase in temperature. When the temperature increases, the resistance also increases for the conductor. So that's mean T naught starting from 0 to 50 degrees Celsius. So that means 0 will be T naught. Okay, be careful with which one is T, which one is T naught. So T naught is 0, therefore T is 50 degrees Celsius. And for T naught, R, the R at that temperature will be R naught. Okay, this is what we are going to find. And therefore, 13 ohm here will be R and 50 degrees here will be T. So this is where students always make common mistake. They make common mistake because they didn't know which one is R naught, which one is R naught T naught, and which one is R and T. So must be very careful. Okay, so now after you determine which one is for R naught, T naught, T and R, then substitute everything into the equation and you get R naught is 10.0 ohm. Okay, so the answer is B. Okay, B. Okay. So next question. Question 11. Okay, a dual range voltmeter has a common negative terminal and two positive terminals. Okay, we have a negative terminal and two positive terminals. Okay, can you imagine or not how it looks like? So one is for full scale deflection of 15 volt, another one is 3 volt. Okay, the resistance of the voltmeter between the 3 volt terminal and the negative terminal is 1000 ohm. So what is the resistance between the positive 15 volt terminal and the negative terminal? Yeah? Okay. So how to imagine the what you call this voltmeter, voltmeter dual range. Okay, so there are two terminal here. One is 15 volt, the top one, the bottom one scale is 3 volt. There are two scale. Okay, full scale, 15 volt and 3 volt. Okay, so there are two terminals here, two terminals. Or we can draw like this. Okay, the first, the 3 volt has R1 1000 ohm, but for 15 volt, we don't know what is the R2. And this is what we are going to find, R2. Okay, so the current flow through this voltmeter is the same. Okay, I. Okay, so that means we just need to use formula V equals to IR. Okay, so substitute the 3 volt first for the R1 1000. Okay, the current is the same. So for 15 volt, current is the same, I times the R2. And we have two equations here. So therefore, we can use simultaneous equation using ratio or substitution method. Okay, it's up to you. So I use ratio method here. 3 per 15 equals to I times 1000 per IR squared. R2, and cancel the I, we get R2 5000 ohm. Okay, not? Okay, so very simple actually. Okay, so next question 12. Okay, EMF of a cell is 1.5 volt and its internal resistance is 0.5 ohm. Okay, so calculate the power supplied to an external resistor of resistance 2.5 ohm. And what is the resistance of the external resistor when the power dissipated from the resistor is maximum? Okay. So we do question A first. How to imagine this? KMF 1.5 volt, internal resistance 0.5 ohm. So the resistance 2.5 ohm here. Okay, external resistance. So what is the power supplied? Okay, power supplied very simple. We use formula P equals to I squared R. This formula comes from P equals to IV. Okay, then we substitute V equals to IR into the equation, then we get P equals to I squared R. So you substitute I squared and R. But the I, you can use a potential divider. You can use, you need to find I first, okay? So you can use the formula E equals to I bracket R resistance here plus the internal resistance. Okay, because this when the switch is on, this is a complete circuit. So the EMF is no longer 1.5 because of R internal resistance. So it's the product of IR, voltage across the resistor here, plus the voltage across the internal resistance here. There is a loss of voltage, so that's why we use this formula. If you can remember in secondary school, you've learned. Okay, so now I equals to E per R plus R. Substitute the E 1.5. R is 2.5 ohm, this one, and the internal resistance. So you get the power is 0.625 watt. Okay. Next, question B. Okay, question B. What is the internal resistance of the external resistor when the power dissipated from the resistor is maximum? So this one you need to know the concept where power dissipated from the resistor is maximum when the resistance here is equals to the internal resistance. Okay, so the external resistance here should be equals to 0.5 ohm. So this is the concept you must know. Okay, it's a direct question only. So the power dissipated is maximum when the external resistor here is 0.5 ohm. Okay, so you can prove this by two methods. Let's just choose example methods. It's simple to understand. When you substitute 0.5 into this equation, the R here, so you get this value. But if you substitute the R less than R, let's say less than 0.5, 0.3, so you use the same I equation, so you will get 1.05, which is less than 1.15. But if you substitute larger than 0.5, let's say you substitute 0.6, so you will get 1.12, and still less than 1.13. This is 1.13, this is 1.12. So still less than the maximum power, you see. So the maximum power dissipated is a maximum when the external resistor here is replaced by 0.5 resistance equals to the internal resistance. Okay, so this is by proving using example, but actually if essay question, you can use this method to prove actually. So the graph for P against R is the curve graph. Okay, for the maximum power dissipated is at the peak of the curve here. So at the peak of the curve, the gradient is 0. Okay, the peak of the curve here, the gradient is 0. So from the P equals to I squared R, so for P against R, you can substitute this I, E per R plus R just now, internal resistance. So you get this. Okay, then you can use the gradient here, okay, which is equals to dP by dR. You've learned this in maths, form 4, form 5. So the gradient at the peak here will be 0. So you equate to 0. Okay, so the dP by dR, you can use quotient rule. Okay, quotient rule in differentiation rule. There are many differentiation rule, right? So one of the rule is quotient rule. So use quotient rule. I just go fast this one. I just mentioned quotient rule. You can Google later, okay, or you can refer to your notes. Okay, use the quotient rule. You get this, and you equate to 0, and you solve. You get for maximum power. R is external resistance should be equals to the internal resistance for the maximum power. Okay, given if on the graph here, the gradient at the peak for P maximum is equals to 0. Okay, this is how to prove it. Okay, using mathematical rules. Okay, qualitatively. Okay, just now by example only, but this is the most appropriate way to prove where maximum, remember this, where power dissipated is maximum when R external resistor equals to the internal resistance. Okay, external resistance equals to internal resistance. Okay, that is question 12. Okay, next question 13. Okay, we are going to sketch a diagram to show the equal potential surface of 4 volt, 3 volt and 2 volt. Okay, so this is the initial position at radius R1. the voltage is 5 volts. So we are going to find V2, V3 and V4. What is the radius? Okay, because sketching must with appropriate what you call it must in with values. When you sketch, you must put the value you calculate calculation, the calculation value. Okay, so you need to calculate first R2 and R3 and also R4. So we use formula V equals to Q per 4 pi epsilon R. But Q 4 pi and epsilon is the constant. So we just use V inversely proportional to R. Okay, so the variation will be V1 per V2 equals to R2 per R1 because inversely, so you can use this formula instead. And you substitute 5 per 4, the V2 is 4, V2 is 4 here, 4. Okay, V1 is 5, okay, 5 per 4 equals to R2 per 10. And you get R2 is 12.5 centimeter. Okay, for V3, you do the same also. This times become 5 per 3 equals to R3 per 10. So you get R3 16.7. And lastly, V4, 5 per 2 equals to R2 per 10. And you get R4 is, not R2 here, R4 typing error. So R4 is 25 centimeter. So now when you sketch, you must be very careful. Okay, for the surface of the sphere, 10 centimeter, the voltage is 5 volt. At a 4 volt, okay, larger distance at 12.5 centimeter. Okay, this is the equipotential surface, which has all the equipotential surface here is 4 volt, has 4 volt voltage. And 16.7 centimeter, another one is 3 volt. Okay, this is the equipotential surface. And lastly is 25 centimeter, is how many? 2 volt, 2 volt. Okay, so when you sketch, you must be very careful. The distance must increasing with each other. From these two, you see 12.5 centimeter and the 10 centimeter here smaller, and it's increasing in distance. Don't sketch at equal in distance. Okay, you sketch at increasing distance between the two circle you've drawn to show the equal potential surface. Okay, this is the correct answer. Okay, then for the graph V against X distance. So V against X distance, so it's a hyperbolic curve, okay, because inversely 1 per RV is inversely to R. So this is for 10 centimeter on the surface. Inside the sphere will be constant. The V is 5 volt, will be constant. Okay, and at the end of the equipotential surface, V4 here, 5 volt. Correct, 2 volt. 2 volt here, 2, 5 volt. This is 2 volt. And it's 25 distance, 25 centimeter distance. Okay, when you sketch, make sure you also put the value, calculated value with your sketch. If not, no marks will be given. Okay, so the two values, 5 volts for 10 at 10 distance, and at 25 distance, centimeter distance, will be 2 volts. 2 volts here. So the curve is a hyperbolic curve. Okay, so if you follow another two equal potential circle, it will show the actually no need to sketch for this one, 4 and 3, just the two ends here, 2, 5 and the 25 and 10, enough already. So this I just show this because to show the curve shape or the hyperbolic shape for the graph V against X. Okay, then one last question. I think still got time, Cikgu, not Cikgu Non, Madam Non. A little bit more, one last question. Okay, we have 4 resistors here, 2, 5 ohm, 10 ohm, arranged like this. Okay, so we have 7 ampere current allowed to flow through the circuit. So the potential difference across RS, what is the potential difference across RS? So we use V equals to IR effective because across RS. So we have all resistors arranged like this between R and S. So therefore we need to find the R effective. So for the R effective, because the resistors arranged in parallel, okay, and that 10 and 5, 2 and 8, 18 ohm arranged in series. So what we can do is 1 per R effective equals to 1 per 10 plus 5 in series, these two, plus 1 per 2 plus 18. Okay, so we get R effective 8.57 ohm. Okay, so you substitute into here, the current flow split into two, but then they join together as the same current. That's why we use 7 ampere, and we get across RS, the voltage is 60 volt. So R to S is 60 volt. Okay, next, for the potential difference across 10 ohm and 2 ohm resistor. Okay, now 10 ohm and 2 ohm resistor. So that's mean this voltage, this voltage shown by the voltmeter here. Okay, so VRP. The potential difference across 10 ohm and 2 ohm. Where? This one, correct lah. So RP, 10 ohm, and also RQ, 2 ohm. For resistor 2 ohm is RQ. For resistor 10 ohm will be VRP. So we calculate VRP first. Okay, for the VRP, the voltage across RS is 60 ohm. Okay, RS is 60 ohm. So that means we can use potential divider formula. Okay, potential divider formula where we just get the ratio of resistance here, 10 per 10 plus 5. Okay, the voltage across RS is the same, 60. So the ratio will be 10 per 10 plus 5 times 60. Okay, these two. Then we get the answer 40 volt. 40 volt. Okay, for RP, VRP. So that means PS will be 20 volt. 40 and 20. For RP, 40. The question asks for 10 ohm only. So 40 volt. What about RQ? So RQ we do the same. So it's 2 per 8, 2 plus 18. We just use ratio, potential divider formula. Ratio of the resistance will be 2 plus 18. So we get V across R2 is 6 volt. 6 volt. Okay. Actually, we can use another method, but for another method, you need to calculate I. So it's longer. The method used is longer and needed means a longer time taken. It's okay. If you want to find current first, it's okay. So you use IRPS equals to V per R effective. Okay, and the R effective between R and S is 10 plus 5 for the R effective, and the voltage across R and S calculated already 60 volt, and the current is 4 ampere. So the current split into two, 7 ampere to 4 ampere and 3 ampere on another path. So for VRP, will be this current 4 times the resistance, 10 ohm. Okay, 10 ohm. So V across RP will be 4 times 10. So you get 40 volt. You still get same answer. Okay, so this is another method. Okay, so the first one without calculating the current, but the second method, you need to calculate the current. Okay, for VRQ, you do the same. The current will be 2 because the current will be 3 because 7 split into 2, 4 and 3. So 7 minus 4 is 3. So 3 times 2 ohm here, the current, the voltage across 2 ohm will be 3 times 2, it is 6 volt. You still get same answer. Okay. Okay, same answer. 6 volt. This one for 40 volts. This is 6 volt. Okay, so for the reading of the voltmeter will be, so what is the reading? So the reading of the voltmeter will be, Okay, across V across RP, we know it is 40. Okay, and the R here will be 60 volt. Okay, because voltage across RS is 60 volt. So that means here is positive 60 volt. Okay, now what is VP? So that means VP will be 60 minus 40. So you get 20 volt. Okay, 20 volt. Okay, now a Q you do the same. We calculate already is 6 volt. V across RQ is 6 volt. But at this potential at R is 60 volt, and it is positive because the current flow here. Okay, flow from from left to the right. So that means 60 minus 6. So you get potential at Q is 54 volt. Okay, 54 volt. Sorry, yeah. Okay, so now compare these two, 20 volts and 54 volts. So that means the reading for the voltmeter will be this 50 minus 20. Okay, so 50 minus 20 will be 34 volts. So that's the answer. Okay, and terminal Q will be positive because 54 is larger than 20. So the current flow from high voltage to low voltage, right? So terminal positive will be 54. Terminal Q is positive and terminal P will be negative. Okay, so that's the answer for question 15. Okay, so I think we have come to the final question already. And Madam Non, are you still okay or not? Okay or not? Not okay. Okay, Madam Non has problem with the sound. Okay, it's okay. With God grace, we have reached the end of today's lesson. Today's lesson. Okay, so congratulations to those who are able to follow the lesson from the beginning till the end. Okay, so before we end our lesson for today,
Can you hear me?
Okay.
Can you hear me?
Can hear, Madam Nun? We are going to announce the last digit code now. The last digit code. So the last digit code is number 4. Okay, the last digit code is number 4. Okay, so all of you please stop posting your comments for a while and click the subscribe button and activate the icon bell so that you will not miss the next class lesson. Then if you find that the lesson was beneficial, so click like and share to your friends, okay, in your social media. Okay, once completed, type done. Okay, type done. In the chat box before the certificate link is given as a token of thank you for your dedication in joining the free online class today. Okay, so looks like Madam Non has a problem with her internet, but it's okay. So I will put the certificate link for you all and the credit claim link in the chat box. Okay, so I will put now. Okay. Another one is the credit claim. Okay. And lastly, my username for you all to claim credit. Okay. So please take note. The link will end half an hour after this live. And make sure to use the EDD email and more email only to log in. Okay, if you haven't got one, please apply. Posted already the EDD email in the above chat box. Okay, if you wish to get more information on the online classes, go to the www.academyyoutuber.com. Okay, and to those who haven't joined EDD Junior Telegram, you can do so. And once again, I would like to thank all of the students for joining today. You are awesome, and feel free to share this free tuition class to your friends and teachers all over Malaysia. Okay, because this is the joint venture of all teachers in Malaysia. Okay, so thank you too for being a YouTuber Academy supporter too. So I think that's all for now. See you another lesson. Remember the hashtag bermula percuma and selamanya percuma. So Assalamualaikum. Stay safe till we meet again next week on Sunday at 5 p.m. So we meet again at 5 p.m. Okay, every Sunday. Okay, bye-bye. Bye-bye.
Wow, banyaknya hadiah menarik menanti anda. Wah, kini Akademi YouTuber mengambil inisiatif baru di mana memberikan hadiah-hadiah ini secara percuma. Ya, percuma kepada anda semua. Bagaimana caranya? Dengan mengikuti kelas tuition online percuma Akademi YouTuber sambil mengutip mata kredit, anda dapat menukarkannya dengan hadiah-hadiah yang menarik ini. Tunggu apa lagi? Segalanya percuma. Jangan lepaskan peluang tau. Dah dapat banyak hadiah menarik, takkan nak lepaskan peluang. Layari www.academyyoutuber.com sekarang untuk maklumat lanjut.
Dibawakan kepada anda oleh Akademi YouTuber.